Hello, my name is Jacqueline Krueger, and today I'll be teaching a lesson on molecular structures. Typically, I would like to be teaching this lesson within a classroom to a group of students. However, due to the circumstances with COVID-19, I'm not able to do so. So in this lesson, I will be teaching to you, the viewer. However, I will be pretending as if I have a classroom in front of me. So at times I will say that I will be giving time for students to respond, or asking them questions, just so you have an idea of how it would be conducted if I was in a classroom with my students. So to begin, I would like to say hello to my class and let you know that we are learning about molecular structures today. So today we will be working with our partners on a lot of activities. And so if you are missing your partner today, I'd like you to come to the front of the class and I will find a partner for you or a group of 3 for you to work in. As we start most of our classes, I ask you to open up your Chromebooks and go to our Google Classroom because I have some opening questions for you. These opening questions will ask some review and they will ask you something new. So you may work with your partner on these questions, and then we will go over them and start the lesson for today. So during this time, I will let my students collaborate with their partner on the questions. I have 3 questions for them that they can access on their computers. The first question is a review question. It asks, what are the components of an atom? Provide a brief description of each part. This is review. I will let my students know that they may use their foldable, which is a method of note-taking that they can keep that has a lot of information in it, so that they may use their foldable. The second question that I'm asking is, what is an element? This is some information that we went over yesterday. So I will let them know that they may use their notes, and this should also be review. Both of these questions will let me know as an educator whether they've learned these concepts or whether they are along the right, following the right pace that I am setting. And it'll let me know, it'll inform me as a teacher if I need to slow down, if I need to go back and review, or perhaps it's too easy. So this is this information is very telling for me, and the responses given by the students will roll in to the Google Classroom, and I will be able to check while they are submitting their answers. And during this time, I will also be walking around the classroom, listening to conversations, making sure that people are on task, and to guide any conversations that seem a little bit lost. I will be facilitating in this time. The third question brings up a new concept to students that they haven't been introduced before in my classroom. So the question is, what are the differences between an element, a molecule, a compound, and a mixture? So this is new for students, and this question lets me see what kind of background knowledge my students are bringing into the classroom, as well as maybe they're guessing. And I would also like to know where their thought process goes when they are asked a question such as this. So, so those are the 3 questions. I'll give my students about 5 to 10 minutes to respond to this, and then we will come back together as a class to review those 2 new questions and then begin the lesson. So I will present, let's see. Present. Okay, thank you for being patient. So molecular structures. Okay, class, so let's review those questions. The first question was, what are the components of an atom? Provide a brief description of each part. Did you use your foldable? Did you look back at your class notes? Did anyone have trouble with this one? I think this one was fairly easy for everybody, but let's see. So listener responses. Okay, so let's go over the definitions. We have an electron, the subatomic particle of a negative charge. Proton, subatomic particle of a positive charge. Neutron, subatomic particle of a neutral charge. So did anyone have any questions about this? Did anyone get a different answer? Anyone have anything to add? Okay, let's move on to the next question. What is an element? So did you look at your notes from yesterday? Did you use a different definition than I gave? Let's see. The definition I gave of an element in yesterday's lesson was that an element is a pure substance which cannot be broken down by chemical means, consisting of atoms which have identical numbers of protons in their atomic nuclei. Did anyone have a different definition than this? Raise your hand if you wrote this word for word. Okay, so those kind of questions provide information for me as the instructor. So what are we doing today? Today we are going to explore elements, molecules, compounds, and mixtures. We are going to be mainly focused on the molecular structure of these, and we want to see how they're different from one another and get a better understanding of what they're composed of and how to recognize them. So we're going to begin with elements. So we just reviewed elements, but again, we will review them. So an element, it's made up of one type of atom. It cannot be broken down by physical or chemical methods. I listed 3 examples of an element. I said oxygen, nitrogen, and carbon. I bet a lot of you can name even more elements. So throw them at me. So hopefully at this moment, the students will be shouting out some elements. Look at the periodic table if you need some inspiration. Okay, so I'll listen. Okay, so let's move on to something new, molecules. So a molecule consists of 2 or more atoms of the same element or different elements that are chemically bound together. A molecule is a singular unit that makes up compounds. So already we're introducing compounds into the molecular definition. So pay attention to that. So, so they consist of 2 or more atoms of the same element. So, and some examples of molecules are water, carbon dioxide, and sugar. Compounds. So compounds form when 2 or more different elements join or bond together chemically. The composition is identical in each sample. You can see this in the little graphic in the corner of my presentation. See how every single one is exactly the same? That's a compound. They can be separated only by chemical methods. So remember when we talked about an element, you can't separate an element. But a compound you can separate, but only by chemical methods. The properties of a compound are totally different than the properties of the elements that form them. So some examples are water, carbon dioxide, and sugar. So the properties of a compound are totally different than the properties of the elements that form them. So they become something entirely new. So let's think, for example, water. So what's the composition of water? Who can tell me what makes up water? That's right, it's hydrogen and oxygen. So hydrogen and oxygen, 2 gases, and they become water. That's pretty different, right? The properties of a compound are totally different than the properties of the elements that form them. Mixture. So mixture is the last one that we'll be going over today. I don't want to overwhelm with too many. We have the core 4. So a mixture is a form when elements and or compounds are combined physically. So remember in the last one, I just said that compounds could only be broken down chemically. Now we're talking about a mixture which are combined physically. So they form when elements and or compounds are combined physically. Properties of a mixture are related to its components. So they take on some of the elements from what they are made of. The composition varies from sample to sample, There's not so much consistency in a mixture, and they can be separated by physical methods. They are combined physically and they can be broken up physically as well. So some examples of mixtures are commonplace things. There's mixtures all around us. Mixtures can be tea, perfume, air, beach sand, oil and vinegar, salad dressing. Mixtures can be, this bottle of water with the plastic and everything, So mixtures are a completely new thing. So during this time, I would like us all to go onto back onto our Google Classroom and look at the article that I uploaded for everyone. We're going to be doing an activity that we've done before, but let me remind you of what the steps are. So you're going to read the article by yourself. I want you to record on a piece of paper 3 things that you have learned, and I want you to write 1 question. So you're going to read the article, 3 things you learned, and 1 question. When you've completed, I would like you to switch with your partner, and that partner has done the same thing as you. That partner will take your paper and will give you their paper. Then you will read the article again. On this second reading, you are going to try to attempt to answer that question that your partner had written. I know it might be kind of hard, but I think, I believe in you. So you're going to attempt to answer the question written by your partner, and then you're going to add 1 thing that you've learned. At the end of all of this, you're going to submit your facts and questions into Google Classroom. So this is not the first time we've done this, but if anyone has any questions, just let me know, or ask your partner first and then let me know if they don't have the right answer for you. So yeah, at this time, I'd like you all to go onto your Chromebooks and access this article. So this is an opportunity where I would be able to walk around the classroom and listen to conversations, make sure that, well, there wouldn't be much conversations, but be looking down, see what people are writing. I don't discourage my students from talking, but during this time when they are supposed to be reading closely to a scientific text, I would like them to be quiet and respectful to their neighbors. So yeah, when they're posting their facts and their questions onto Google Classroom, that will show it for me instantly. So I can walk around, go back to my computer, see what people are putting in. This article is about elements, compounds, and mixtures. It goes over molecules as well, but it's not listed in the title of the article. But this is an opportunity for the students to engage with the material in a different context and to interact with their partners and their peers about the information that they've just read. It's not a lot of new information that we didn't just go over, but it does provide a little more context for these for the elements, molecules, compounds, and mixtures, and more about their molecular structure, and has more diagrams. So during this time, students will be reading and writing and posting their responses. And based off the questions, I may bring up some of the questions if I have answers readily available, and if not, and if time is running too short, I will bookmark all of these questions for a later lesson so that we can come back to it, hopefully the next day's lesson, so that I can make sure to check in and let them know, if they're pondering about certain things. I want to make sure that I get them the answers that they're searching for. Okay, so for today's activity, we'll be making models to represent elements, molecules, compounds, and mixtures. So remember, we talked a lot about the molecular structure of these, of the elements, molecules, compounds, and mixtures. So in this, you'll look on your desk, and I've provided everybody with a bowl of marshmallows and toothpicks. And for this activity, the marshmallows will be elements, and the toothpicks will be their bonds. And to do this, we're going to start by getting a piece of paper. So rip a piece of paper out. We're going to be working with our partners. So you only need one piece of paper per pair. If you're working in a group of 3, still one piece of paper per group. Make sure everyone pulls out a piece of paper. So to begin, I want you to fold your paper in half and then in half again. So your paper is folded in quarters. Unfold so that you can see distinct fold lines, and you have 4 sections. Can anyone guess what these 4 sections will be labeled? That's right, elements, molecules, compounds, and mixtures. So I would like you to label them. So this is what I've done. Elements, molecules, compounds, and mixtures. And also I would like everybody to write your name at the top of the paper so that I can know who they belong to. Once I've seen everyone has done this, we will move on. So we will be sorting today. We're going to be testing our knowledge of how well we understand elements, molecules, compounds, and mixtures, and how we would construct them. So based off of the definition that we've been given, and I know that we already have some familiarity with how bonding works in some compounds, and you'll recognize all of these compounds, mixtures, molecules, and elements. You'll recognize everything that I've listed here. Nothing is new information, and if it is new to you, feel free to ask, and I will provide you with that information or guide you to that if you've forgotten. So I've listed everything, and I would also put this on the board so that when I switch this slide, it still shows up. We will be sorting and creating carbon, hydrogen, chlorine, oxygen, sodium, hydrogen diatom, oxygen diatom, water, carbon, dioxide, methane, and salt water. So kind of a mouthful. I promise that we will get through it. And I helped you out right here. These are all your elements. So you have your elements page already done. The marshmallows are elements. So when the marshmallows are elements, do we need to be doing any bonding? No, right? So you'll also see glue on your desk. So I'm going to ask you to glue your marshmallows down on your paper, but don't cover the entire square. Don't fill up the entire square because I want you to leave room at the bottom of each square for examples. In fact, you can even write above the line right here, example, 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 example. Because I want us to think about other examples for the different sections. Everyone following? So let's do elements and molecules together, and then I'm going to let you loose with your partner for compounds and mixtures, as long as we're all following along. So elements. So we see the elements right there, but I want us to think of what are some examples of other elements? We talked about this earlier, but I want you to think. Talk to your partner about other examples of elements. So this is hypothetically what their page will be looking like. So I'll give time for my students, and I'll present this after I've noticed that they've already put down on their page their marshmallows and their examples. Okay, now let's talk about molecules. Who remembers some of the distinct characteristics of molecules? Discuss with your partner what makes up a molecule. You can refer back to your notes. So this would be time that I let my students discuss and think about it. So let's look back at, it'll be on the board, but for this purpose, I'm going to scroll back. What do you think off of this list makes up a molecule? Remember, molecules consist of 2 or 3 atoms of the same element or different elements that are chemically bound together. So it consists of 2 or more elements of this, 2 or more atoms of the same element or different elements. So discuss with your partner off of this list what fits the characteristics of a molecule. I'll let my students talk, discuss, and come back. Who can raise their hand and tell me what their partner came up with for what is a molecule according to this list? So hopefully students will be coming back to me with oxygen diatom, hydrogen diatom, and water as the 3 molecules on this list. So we know which ones are molecules, but how do we construct them? I want you, don't glue anything down, but I want you and your partner to work with the marshmallows and the toothpicks and try to construct these molecules. Let me do the first one with you. Oxygen diatom. So who can tell me what is in oxygen diatom? 2 oxygen, right? Oxygen diatom. What does this look like? O2. That's right. You can write it on the board. So do the 2 elements, do they just squish together? Is that how they bond? No. We're going to use a toothpick to bond it. So you're just going to put the toothpick on one side, toothpick on the other marshmallow, and there you have it. We have our oxygen diatom. Perfect. Can you do the same for the hydrogen diatom? During this time, I'll be walking around making sure that students are following, that they completed the elements section, and that they're collaborating with their partner and there is conversation happening. So does your response or does your corner look something like this? Can somebody raise your hand for your partners and tell me some examples of a molecule? Okay, great. So for the remainder of this activity, I would give my students the opportunity to work with their partner to finish the squares, to work on compounds and mixtures. I'll be walking around during this section to make sure, just to facilitate the activity, make sure that the conversations are on topic and that if anyone's struggling, that I can point them in the right direction. This is an opportunity for students to really engage with their learning and play with the materials and really think more critically about the definitions of these different items. So I'll give them a lot of time to complete this and then we will discuss. So compounds, I was looking around and I saw compounds on your papers. And did anyone else notice that water came up again? Yeah, water came up again. And did you also notice the bonding in carbon dioxide? I know some people miss that, so let's add that. So you want to add an additional toothpick to make sure that, that the carbon dioxide has the double bonds there, like it normally would. And what are your examples for the compounds? So who can tell me what the distinction is from a compound and a molecule? Because it looks like water is in the compound and molecule section. And why is that? I'll gather students' responses. I'll see what their line of thinking is. and then I'll again review what a compound is based off the definition that I provided them. So to review again, a compound is formed when two or more different elements join together chemically. The composition is identical in each sample, and the properties of a compound are totally different than the properties of elements that form them. So they form when two or more different elements join. So compared to the molecules, in molecules we had the oxygen and hydrogen diatoms. These were the same elements that are bonded together. The difference is when you meet a compound, you don't have that. You have, well, you have some, like water has, it's H2O. So we have two of the same element within, but overall we are is diversified. So let's move on to what you guys got for mixtures. So there was only one mixture on my big list of things to sort. Who knows what that mixture was? That's right. It was salt water. Now, I saw that some people attach the salt and water. So mixture is, so let's go over mixture form is when elements and or compounds are combined physically. They're not combined chemically. So the salt and water are separate from each other. They were physically combined, and they can be physically separated as well, but they are physically combined. So I want to see on your paper that salt and water are not touching. And what are some examples that you got of a mixture? So I'll listen to some examples. And for my examples, I put pizza, soda, salad dressing. Those are all examples of mixtures. So that's what I put. So I'll walk around, make sure that all of the students have combined this and fixed their problems or where they needed adjustments, like if they needed to put the double bond in for carbon dioxide, if they need to separate salt and water. Yeah. So their final product, and I'll present this to my students as well, will look something like this. Hopefully it stays on there. And I'll walk around with the final product so everyone can see at least what I came up with. And I'll also let my students know that if they have extra time, if they finish early, they're more than welcome to create more elements, molecules, compounds, and mixtures onto their paper as long as there's enough materials for everyone to finish the basis of their project. So thus concludes our lesson. We have an exit ticket, which will be done individually. So this is our one time that we're not working with our partners today. So partner exit ticket. Yeah, or you can complete with your partner if you need this, but I would like you to answer individually so you can really test your own knowledge. If you would like to submit with your partner, I would like you to at least internally have a conversation with yourself on how you would describe these different things. So what are the differences between an element, a molecule, a compound, and a mixture? So I want you to go to your Google Classroom and you'll find this question waiting for you. And I would like you to the best of your abilities answer this. This is a time that I would actually ask you not to look back at your notes. I want to see what you've soaked in. You may look at your marshmallow molecular structures that you've just composed, but I would like you to just use what you can remember and what you've learned and the structures that you've made. So this will be the last 5 minutes of class, and during this time, students will also I will ask to collect the structures and the papers from the students so that I can have them waiting for them in the next class period so that they can refer back to them. The marshmallows, I don't want to be having them in my classroom sitting for a long time, but at least for a couple days, I'd like that to be visible for them, and they can take them home after a couple of days if they would like to, or they may throw them away. But that is my lesson for molecular structures. I think this is a really effective way to show students the differences between an element, a molecule, a compound, and a mixture in a way that is more tangible for them. And I think the use of a scientific article within the lesson gave them not only the opportunity to discuss their ideas and to see the information in a new context, but to really engage. And when they, I asked them to ask questions, which will help guide my future lessons. But it also has them think more critically about what they are reading. So this was my lesson for today, and thank you for watching.